Now I want to explain you how to find the inverse of a matrix using minors and cofactors. To obtain the inverse, first we need to calculate the adjoint of a matrix. Question raised, what is the adjoint of a matrix? If in place of elements in any square matrix, their corresponding cofactors are written and then matrix is transposed. If after writing the cofactors in place of elements in any square matrix is being transposed, then result so obtained is what known as adjoint. And if adjoint of any matrix is divided by its corresponding determinant value, that value obtained is known as the inverse of matrix. To obtain the inverse directly without row column transformation or any other approach, first we need to find the elements and corresponding cofactors. I am taking a problem. Find the inverse of the matrix A equals to 1, 3, 3, 1, 4, 3, 1, 3, 4. To obtain the inverse, very first I need their corresponding cofactors, which I explained you how to obtain the cofactor in my previous video. Suppose I want to obtain the cofactor of the first element, that is 1. 1's position is A11. To obtain the cofactor, I need to calculate first its minor. The numerical value of minor and cofactor always remains same, only sometime their sign gets changed or sometime not changed. It change if the sum of the row and column for the element is odd, then it get changed, and if the sum of position of row and column is even, it doesn't change. So first is what? 1. Its location is given by A11. First row, first column is 1. To obtain its cofactor, I want to tell you first how to obtain its minor. This is the method that row and column will be hide where the element is lying. Then remaining are 4, 3, 3, 4. 4, 4 just 16 minus 3, 3 just 9. 16 minus 9, the result is 7. The minor is 7, but here cofactor will also remain 7, with the reason that the position of the element is first row, first column, 1 plus 1, 2 is even. So for first element, the cofactor is 7. For the element A12, first row, second column, element is 3, its corresponding cofactor. I want to tell you how to obtain first its minor. 3 is lying in the second column and in the first row. When we will hide it, we will left with 1 4 ja 4 minus 3 1 ja 3. So as and when we will obtain 4 minus 3, the result will be 1. But I am writing the cofactor minus 1. Minor was 1, cofactor is minus 1, with the reason that sum of the position of row and column is what? Odd. 1 plus 2, 3. So minor was 1, so cofactor is minus 1. Same way I have written, you need to calculate all the cofactors for each element. A13 is what? 3. Then similarly you have to write its corresponding, all the cofactors are required to calculate. A13 is 3, its cofactor is minus 1. A21, second row, first column is 1, cofactor is minus 3. A22, second row, second column, the element is 4. To obtain its cofactor, second row and second column will be hide. 1 4 ja 4 minus 3, that is 1, will remain same because position sum is what? 4. So I have obtained all these cofactors for each element, and now to obtain its adjoint, what I need to do, simply all the elements will be replaced by their corresponding cofactors. Now after obtaining all the cofactors, I need to put in place of these elements value, I need to put their corresponding cofactors value. C11 is 1, in place of 1 I need to write its corresponding cofactor, that is what? 7. Then Similarly, 3 will be replaced by what? Minus 1. This 3 will be replaced by what? Minus 1. This 1 will be replaced by what? Minus 3. This 4 will be replaced by what? 1. This 4 and so on, and I need to do the transpose also. So after writing the cofactors in place of the element and doing the transpose, I have obtained the adjoint as 7, minus 3, minus 3, minus 1, 1, 0, minus 1, 0 and 1. This is the adjoint as initially I told you that in any square matrix, if the elements are replaced by their corresponding cofactors and doing the transpose gives us adjoint. How to find the inverse? To find the inverse, we need to calculate one very important thing here, that is determinant. The determinant value will be obtained by multiplying element and corresponding cofactors of any row or any column. Here 1 7 just 7 minus, then this is minus 3, second is 3, its cofactor is this. So plus 7, first element and first cofactor, second element and second cofactor of the first, it is minus 3, 7 minus 3, what we will get? 4. After it, only one element is left, that is 3 1 ja 3, minus 3. So 4 minus 3, what we will get? That value will be equal to the determinant value of this, which I can tell you, and I also explained you earlier that if we take any row or any column and we multiply it with corresponding elements, 1 into 7 plus of 3 into minus 1 plus of 3 into minus 1, minus 3, minus 6 and 7, 7 minus 6 is what? 1. This is the value of determinant. Determinant of A is 1, and the formula for obtaining the inverse of a matrix is given by when adjoint is divided by the determinant. The value so obtained is known as the inverse. A inverse is equals to adjoint of A upon determinant of A. In this case, determinant is 1. So inverse will be this adjoint, that is 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. This when divided by what? 1, because determinant obtained was 1. So this value so obtained is the inverse of this matrix, and the rule for the verification is whenever you multiply any matrix A with its inverse, the answer comes identity matrix. So their product will be 1 0 0 0 1 0 and 0 0 1. So with this help you can verify your answer and you can obtain the inverse of any matrix.